Welcome to the Z-Hut. Today I would like to show you how you can build your own Bluetooth controlled garden hose. Now what this is we have here a latching solenoid. Now a latching solenoid, what that is it's energized and it turns on, but it's only energized just for a quick moment. And then to turn it off, you switch the polarities and just energize it again quick. So what it does is it latches, either open or closed. So you do not, like a normal solenoid, when you have power applied to it, it's open. When you disconnect the power, it closes. This is a latching, and I prefer to use these because they use a lot less power. You could actually even battery control this or run it off solar panel. Then you wouldn't have to worry about plugging it into a wall plug. But again, outside, if you have this near the house where the garden hose is, most likely you will have a plug-in, so you could use a wall wart to power it as well. But yeah, make sure you're using, if you're going to build this, use a latching solenoid. I actually scavenged this one out of a watering timer, and I got it at the Goodwill. It didn't work anymore, but the solenoid inside, nothing wrong with it. And it actually has the garden hose end on one end, the other end it's the right size to fit the hose, and I just have to hose clamp it on. All right, well, why don't I demonstrate it working here, and then we'll take a look at how the circuit's put together, and then we'll go over and I'll show you on the computer how whether you can just download this app if you don't want to build it yourself, or I will go through and I will show you how it's put together. And then we'll go over to the Arduino sketch and take a look at that. So let's take a look here at it working first. So I'm going to open it up. When it opens up, it just has this big connect with the Bluetooth symbol, and just touch anywhere on the screen and it brings up your list of Bluetooth devices. Now I renamed mine garden hose so I know which one to choose. It should connect pretty quick. There, now it is connected. So I have two features on here. One, it's just a turn on and turn off. And another one, it's a timer. So you set an amount of time anywhere from 1 minute to 60 minutes, which would be 1 hour, in increments of 1 minute. But I'll show you this first. This is just on or off. So when you click it on, the relay, or excuse me, the solenoid will turn on. I don't know if you could hear that click or not. But I also have an LED here so you know when it's on. And then when you want to turn it off, as you see it now, it says turn off. You click that, it turns off. So on, off. Now when this turns on, it makes a louder click than when it turns off. I'm guessing it has to do with how it seals. There's probably a rubber gasket of some kind down there. So it doesn't make as much noise when it closes, but it is turning off and on. And there's off. All right, let's check out the timer function. So when you push the timer function, everything else disappears, and you have a slider, and you can select anywhere between 60 minutes, which is an hour, all the way down to 1 minute. So I'm going to go ahead and start it at 1 minute, and then also once you click start, it turns on and the application automatically closes because there was no back button. Once you go into this, if you want to stop this, if you put the wrong time in or something and you don't want it to go that long, you actually have to go out and disconnect the power. Once this starts, because the Arduino is in a delay, waiting to count down the amount of time, there really is no way to send a Bluetooth signal to it and tell it, no, stop, that was the wrong value. I'm sure there is somehow to do this, and I'm looking into it using interrupts. I haven't gotten around to that, and these tutorials I'm doing are for more beginners to intermediate, so I'm not going to go into something real technical like that. But all right, let's take a look. I'm going to move the tablet out of the way, and let's take a look at how this is put together. Now, first off, if you want a schematic, if you're going to be building this yourself, look in the description below. You'll find a link to the website. You go there, you can download and print it out, or maybe you got your tablet or whatever, you can just put that in front of you. But however you want to do it, the schematic for how to put this together is on there, as well as the APK file for the app. All right, with that, like I said, just go to the website, You find everything there, all the information you need. So we have, of course, is the first part, we have our latching solenoid. We already went over that, and we have an Arduino. You can use any Arduino board. I'm using a Nano on this project because it's nice and small. And I'm using an HC06 Bluetooth module, and HC05 will work just as well with this. It wires up just the same. And then, of course, because the HC06 or 05 is 3.3 logic and the Arduino is 5-volt logic, we are using a logic level converter. And they're extremely cheap. You can use a voltage divider if you really want to, but I prefer the logic level converters. They are super cheap. I mean, you're talking less than $1 for that little part. Probably like 50 cents if you order a few of them. Now, also I have a LED in here that is optional. I pretty much put that in just for the tutorial because it is kind of hard to hear if the relay is clicking, or not the relay, the solenoid is clicking off and on. And also I don't have any water hooked up to show it shooting out when it opens, so I put the LED in there. It's optional, you know, you might want it, so if you walk by you can look to see is it still turned on or not. Now to control the latching solenoid, we are using an H-bridge. And this is something that's commonly used for controlling stepper motors and also regular DC motors to control the speed and direction. But we are using H-bridge because we need to switch polarities to turn it off and then switch it back to turn it on. Now I'm using right here the L298N, very common. The only reason I actually used this one on this project is because of the ease of how to hook it up. I also have these. These are L293Ds. These are H-bridges as well, but they are little chips. And this, for this project, you definitely could easily use these little chips because this is turning off and on so quick, it's not going to have time to heat up and damage it. So you can go ahead and use these little chips and not worry about putting heat sinks on them. You can also, if you want, you can use transistors and you can build your own H-bridge. I've seen 2 different versions, one with 2 transistors and that was using NPNs, and I've seen another one that used 4 transistors, 2 NPNs, and 2 PNPs, and I also ran across another one that just used 4 NPNs. And you can just use, you know, basic like the 2N222s or the 2N3904s, just the super cheap common ones, because this is turning off and on so quick, just to get it to latch open and close. You're not going to most likely damage the H-bridge or the transistors or whatever you're using. If you were using a really big solenoid and you were going to build it yourself, I wouldn't use these, of course, but I would use this. Or if you were going to build your own H-bridge, use Darlingtons or MOSFETs. But all right, I think we've went on enough about how this is put together. As you can see, it's not that hard. Not that hard at all. So I'm going to get the computer turned on. Excuse me, I'm going to get the computer turned on. I think we'll go over to MIT App Inventor first and take a look at how to put this the application together that controls this, and then after that we will go over to the Arduino IDE and take a look at how to put the sketch together. And like I said before, if you don't want to write type do any of this, you can just go to the website. You can download the APK file, install it on your Android, and MIT App Inventor is actually not too much longer. They're coming out for iPhone. Once they do, I will make the iOS, the Apple iPhone app available as well. And the sketch, you'll find that on there. You just copy and paste it in your Arduino IDE. So, all right, I'll catch you over at the computer in just a second. Alright, I got MIT App Inventor opened up here. So the first thing we're going to need to do, so you can see everything that's on here that we need for this app, is I'm going to display hidden components, and then I'm going to go down and make this scrollable. Just remember, you don't want this to be scrollable when you save it, so make sure that is not checked. I'm just got it that way so we can see everything that's on here. So what we are going to need, of course, is a list picker to connect to our Bluetooth device, and that's this right here. And I just simply used a Bluetooth picture in there for the background. Then we're going to need a button here. This is the on and off button. And when we get over to the blocks here in a moment, I'll show you. In the blocks, it'll actually, when you click it, it'll make this go to turn on, to turn off. Then, well, this got stuck down here. This is the timer. This would actually show up underneath the turn on and off. This is just another button, and when we click this one, it brings up so we can see these. This button here, which is the start button. Then we have a label here, and this is the time, and it's displaying what's being selected on the slider. We also have two spacers, spacer 2 here. That's just a label, and it's between the start and button and this label, just so there's a little space so it's not all crowded together. And then this other spacer, spacer 1, that's a spacer that only shows up, and that shows up between the turn on and the timer button that you see right after you connect to your Bluetooth device. Other than that, the other two things we need is we need a Bluetooth client, and you can find that under connectivity. Just make sure you drag in the client, not the server. And also we need a TinyDB, and what we're using this for is to store the value so that we know if this should say turn on or turn off, and then what value to send over Bluetooth to the Arduino to tell it will turn on or turn off. Alright, let's go over to the blocks. Scroll up here to the top. Now what we're doing here is when the screen 1 initializes, we are calling the TinyDB, and we're just setting the state, that's the tag we're using, state, and that's for the off and on. And we're just setting that to 0. So whenever it restarts, if you accidentally lose connection with the app in your Arduino, the Bluetooth Arduino module, when you restart it, you'll have to click the turn on button once, and then when you click it again to turn off, it will turn your Bluetooth off. It's simple enough. I hope that makes sense to you. Because you might accidentally lose connection, you turn it on, you walk out of range or something, and it'll lose connection. When you relaunch the application, reconnect to the Bluetooth, it will just automatically start it up as it's being off. So you just hit the turn on, it won't do anything, but then you hit it, it'll say turn off. You hit it again, and it will turn your water valve off. Next we have our list picker, the before picking, and we're just setting the Bluetooth addresses names. Then after picking, we're connecting, of course, to the Bluetooth module that we selected. And then what we're doing is if connected, because we were using virtual screens there and buttons, because you don't want all the buttons to show up if they're not being used. So that's what we're using here. After you select and connect to your Bluetooth device, it just turns that list picker off, so you don't see it anymore, and it turns the on-off button visible to true. That spacer that goes between the timer buttons true, and then it makes the timer button true. So what we have here next is when the on-off button is clicked, we're just taking and we're calling to see what value is stored in state. Now for some reason if nothing's there, it's going to go ahead and say it's 0, but it should have a 0 in there if nothing's been done. So what it's doing is it's checking if it equals 0, well then it's doing a Bluetooth send a 2-byte number. And remember, use 2-byte number, not 1 or not 4. Use send 2-byte number. And we're sending the number of 100. And then what we're doing is we're setting on-off button text to turn off because it's on. So now the button says, you know, if you push it, it's going to turn it off. Then we're setting that tag, that TinyDB, we're setting that state to 1, which means now it's on. So otherwise there's an else. If what basically it's doing is checking if it's the TinyDB has a value of 1, means that it's on, it's doing a Bluetooth send 2-byte number, sending a value of 200, then setting the text to turn on, because now we've turned it off. If we push the button again, it'll turn it on. And then we're setting the value of the TinyDB, the state tag, to 0. Next, when we click that timer button, well, we're getting rid of the on-off button. We don't need that. We don't need that spacer. We actually don't even need to see the timer button anymore, so we're getting rid of that. Then what we're doing is we're making the start button visible, the spacer visible, the label that shows the amount of time visible, and the slider itself visible. Next, what we're doing is when the slider position changes, what we're doing is we're writing that value to, and we're rounding it, and we're putting it on that the text, that label that displays it. So we're rounding it. So whenever that thumb changes, it's putting that value into that label. And then we're sending that to the Arduino. And of course, again, we're rounding it and we're sending the thumb position. Now, when we click the start button, so we've got our time set, we click start, it's going to send a value of 300 to the Arduino. And when we get over to the Arduino sketch, you'll see why these numbers are being sent the way they are. What we're doing is we're sending a value of 300. Then we're disconnecting the Bluetooth and we're closing the application, because there's no back buttons in the application. Once you start this, there's no reason to keep it open. So it's just closing it down. And like I said before, if you accidentally put the wrong amount of time in, you're going to actually have to go out and disconnect the power to the Arduino and then repower it up, and then you can go ahead and connect and use your Bluetooth control with your Android or iPhone and send the values again, and hopefully you get it right that time. I don't see having to do that very often. It's like just maybe you weren't paying attention and you had 30 on there instead of 3. But all right. Then also I have, when the back button is pressed on the app, it just disconnects and closes the application as well. All right, I hope all that made sense. If you have any questions, I missed something or anything, just leave a comment below. I will try to get back to you as soon as possible on that. All right, well, let's go over to the Arduino IDE and check out the sketch for this now. Okay, I've got the Arduino IDE opened up here. So let's just get right into it. So what we're doing first is we're doing some defining for some pins, and we've got our LED, and I have that on pin 13. So remember, you don't have to actually add an LED to the circuit. The Arduino itself does have the built-in LED on pin 13, so that's why I chose that. Next, we're defining S1 and S2, and those are our 2 digital pins. We're using pin 11 and 12. That's what controls the H-bridge to tell the solenoid valve to either open or close. Then we have an integer here, and this is called timer, and we start at 1 because you remember when we had the timer, when you open it up the app and you hit the timer, it automatically says 1 and then start. If you don't change the value of the slider, it won't send any number to the Arduino board, so that's why it starts at 1. So if you just hit start without changing the slider, that's where it'll be. So the timer will be at 1, and that'll tell this to only water or turn the solenoid open for 1 minute. Now down in the void setup, we're of course starting our serial. If you want to use a different baud rate, just make sure you change it on your Bluetooth module as well. Then we're doing the pin modes. The LED, of course, is output, S1, S2 is output. Then we're just digital writing S1 and S2 low. It should be low, but just in case, I like to be safe. Next, we're going into the void loop, and what we're doing is we're checking if serial.available is greater than or equal to 2, because we are sending 2-byte numbers to the HC05 or 6, whatever Bluetooth module you use, but the Arduino itself only receives in 1-byte numbers. So what we're doing is this little formula right here. Don't change any of this or it will not work. This takes those 2 1-byte numbers that it just received, combines them together, and it comes out to be that 2-byte number. Now the reason I like to do it this way instead of just sending 1-byte numbers, even though we are sending small values, I just do all my apps this way, because by using 2-byte numbers you can send really big values, to where 1 byte it's not as big. And for some reason also, it just seems to work better to send 2-byte numbers from MIT App Inventor apps to your Bluetooth modules. It just seems to work better. I have done sending 1 bytes, and I get glitches and stuff. So I do suggest doing it this way, and just don't touch this formula at all. All right, moving on. Now we're doing our if statement. So if we receive a value of 100, which means the turn on button was pushed, we're digitally writing S1 high, and then we're just a quick delay, and then writing it low to turn it back off, and then we're turning the LED on, writing it high, and what that does is it's opening the valve. Otherwise, else, if we get the value 200, it's doing the opposite. It's just closing that valve and turning the LED off. Otherwise, we have another else if, and this is if we get a value between 1 and 60, it's setting that timer value to that. So whenever that slider is moved on your smart device, this is where it's storing it. Now we have one final else if. The value is 300. That means we're on the timer, and you hit start. So it's digital writing the LED high, turning the LED on so you know it's on. And then it's writing S1 high, and then a quick delay, and then writing it low, because of course we're using a latching solenoid. So the solenoid's now open. Now what we're doing is we're taking that timer value from 1 to 60, and we're timesing it by 60,000. And that's our delay, because 60,000 milliseconds is 1 minute. So if we have a 1, the timer set at 1, we're delaying 1 minute. If it's set at 60, we're delaying 60 minutes or 1 hour. Then we're digitally writing the LED low, digital writing S2 high really quick with the delay here, and then back low, which means it's closing it. All right, and that's it. That's how you do this. Now there's some other things you could add. You could also add in a little clock module and have this set up also every day where it could automatically water. And there's other things you could do with it, but for how I have this set up, and this is more for beginner to intermediate person getting into Arduino, this should be a fun project, and it's useful. I mean, you can turn your garden hose on, your sprinklers, maybe have the hose hooked up to a trough for watering animals, and you could just sit in your living room, look out the window, push the buttons on the app, and bam, does it for you. You don't have to go outside. All right, with that, we're going to wrap this up. And just remember, all the information, the Arduino sketch, the AIA, the APK, all that, just look down in the description below, go to the website. You'll find all the information you need there, parts list as well. So, all right, well, I'd like to thank you for joining us here at the Z Hut today. I hope you found this information useful. If you did, please give me a thumbs up. I'd appreciate it. I really would, big time. So with that, we'll say I hope you have a great day. And remember, have fun building.